Assalamualaikum and salam sejahtera. Welcome to the online learning course for the Principle of Computer Networks. This course will be taught by 3 lecturers, me myself, Professor Dr. R. Badlisha Ahmad, and also Dr. Latifah Munirah Kamaruddin. In this video, we are going to start with Chapter 1 that will cover about the computer networks and the Internet. This chapter also covers basic protocol explanation and how networks are physically interconnected, types of transmission medium, and types of network device entities. This chapter consists of 8 topics. But for this video, we are going to cover just the first 2 topics, which are the Internet principles and the protocols that govern the Internet. The rest of the topics will be covered by the additional materials provided for this chapter in the Open Learning website. Before we start, let's take a look at the current fact about the Internet. As of August 2015, there are more than 3 billion Internet users all over the world. This figure has reflected that around 40% of the world population are connected to the Internet. Out of this number, the largest users are contributed from China, India, and USA. So let's get started and learn more about the Internet and enjoy. So let's get started. What do you understand by the word Internet? Either this one, this, or this. By definition, an Internet is actually a massive network of networks. It is used to connect a computer to any other computers in the world. An Internet is also an interconnected computer networks that provide users with a connection to the outside world. Or in other words, using an Internet, millions or billions of computing devices can be globally connected. In networking terms, these computing devices are known as host or end systems. Not too long ago, these computing devices were just the traditional desktop PC, Linux workstation, and the servers. Increasingly, however, non-traditional end systems such as laptops, tablets, smartphones, televisions, and sensing devices are being connected to the Internet. These end systems are connected to the Internet using communication link and packet switches. The communication links consist of copper wire, coaxial cable, and fiber optics. The connection can be either wired or wireless. On the other hand, the packet switches comprising of routers and switches. Let's take a look into more details on the communication links and the packet switching. This is part of the communication link example, which are coaxial cable and fiber optics. When one end system has data to be sent to another system, these communication links will segment the data or messages and add the header bytes information to each segment. This header byte information consists of the sender and receiver address. The process of adding the header is called encapsulation. When the data arrive at the destination, the end system will reassemble the packet back into the original data by removing the header information and combine the data into a whole big chunk. This process is known as decapsulation. The packet switches, on the other hand, will filter and forward the data packet to the destination address. Routers will choose the best forwarding path to forward the packets to the destination. This figure shows how the encapsulation and decapsulation process taking place in the OSI layers, which is the Open System Interconnection. Each layer is served by the layer below it. Every packet is actually sent by the end user at the application layer and travel through multiple layers until they reach the first layer, which is the physical layer. The header information is gradually added starting from the transport layer with the TCP and IP at the network layer. At the data link layer, the Ethernet information will be added, that is at the sender side. At the receiver side, the packet will be traveled from the bottom layer to the top one. At each layer, the header information will be removed until the original message is assembled. Having said this, the access to the Internet is actually made viable through Internet Service Provider, the ISP. The ISP is an organization that connects business or residential to the Internet. Or in other words, it's a company that provides access to the Internet. Among the well-known ISP in Malaysia are Telekom Malaysia, Digi, Celcom, and also Maxis. As shown in the figure, the connection provided by the ISP are normally done through tiered hierarchy. The lower-tiered ISP are connected through national and international upper-tiered ISP such as AT&T, Sprint, and NTT. The upper-tiered ISP consists of high-speed routers interconnected with high-speed fiber optic links. We can also describe the Internet in two ways. From the nuts and bolts perspective, which are the components that make up the Internet, and also from the service view. The end system accesses the Internet through several interconnected ISPs such as corporate ISPs, university ISPs, Wi-Fi at the airport, and much more. Each ISP can provide a variety of network access such as broadband access, DSL, high-speed LAN, or wireless access. The end systems and other components run protocols that controls the sending and receiving of messages through the Internet. Among the well-known protocols are Transmission Control Protocol, the TCP, the Internet Protocols, the IP, and the Hypertext Transfer Protocol, the HTTP. The IP will specify the format of the packets, while the TCP is a standard that defines how to establish and maintain a network conversation by which the application program can exchange data. These protocols follow an Internet standard which is developed by the IETF, or the Engineering Internet Task Force. The IETF produced a series of formal documents called the RFC, Request for Comments. Each RFC is designated by an RFC number. Once published, the RFC never changes. Modifications to an original RFC are assigned a new RFC number. Up to this point, we already learned about the components that make up the Internet. Now, let's take a look at the Internet from a different angle, namely the infrastructure that provides services to applications. Examples of the applications are web surfing, voice over IP, instant messaging, video streaming, and much more. These applications are called distributed systems because they involve multiple end systems in exchanging and transporting the data. Now, let's take a look at the API. An application program interface, or the API, is a set of rules or routines that the sending program must follow so that the Internet can deliver the data to the destination. It is also a specification written by the providers of a service that programmers must follow when using that service. In other words, the API specifies how software components should interact. Okay, let's see a simple analogy in order to understand more about the API. Suppose Bob wants to send a letter to Alice. Can he simply write the letter and drop the letter out his window? Can the letter reach Alice using his method? No, right? Instead, Bob has to put the letter in an envelope, put the stamp on it, and seal it. Then, he has to write the recipient's name, postal address, the zip code, and finally, send the letter to the post office so that Alice can receive it. So that is called the API, the simple rules that we need to follow. The last part of this video is the protocol that governs the internet. So what is a network protocol? A protocol is a formal rules that govern how the computers and other network devices exchange information over the internet. It defines the format and the order of messages exchanged between two or more communicating entities. Two entities have to run the same protocol in order to accomplish a given task. Different protocol is used to accomplish different tasks. For a better understanding, it's probably easiest to first understand some human analogies as shown in the figure. Consider this woman who wants to ask the time of the day from this man. So she will start by greeting the man with hi and then wait for the reply. If the man replied positively, then she can continue to ask about the time. If she didn't get a good response from the first greet, she can forget about her original intention. So both the woman and the man have to follow the same protocol in order to complete the same task. If they don't follow the same protocol, no communication can take place. A network protocol is similar with the concept of human protocol, except that the entities that exchange the messages are machines such as computers, smartphones, tablets, or routers. In order to establish a connection, the sender has to request for TCP connection from the server and wait for the response. Then the recipient will respond with the acknowledgement of whether the connection can be established. Upon receiving the acknowledgement, the sender will send the address of the requested page. The server will then respond by giving the corresponding file or page. Okay, I think that's all for now. I hope you enjoy learning through this course and hopefully you get some meaningful information. Don't forget to find the rest of the topics from the following URL. Thank you and see you again in the next chapter.